Okay, picking up where we left off on page 350, now we're talking about USB flash drive. So this is just a typical one. You know, it's just a thing with all the storage on the inside and just has a stubby little USB connector on the end. And of course, these guys are designed for portability in mind. And so you plug one of these guys into an available USB port and presto changeo. So they are typically faster than a storage card, you know, like a micro SD card typically, but not near as fast as a full-blown SD hard drive, right? So they're kind of in between, but these guys are cheap, they're portable, they're designed to plug into practically any device, and I kind of like them. Okay, next on page 351 they talk about cloud storage. And so instead of having me have a physical device, I can use something like Dropbox. And so let's do this. Let's go here to Dropbox someplace. And so I'm just going to type in, you know, www.dropbox.com, right? And if you have a Dropbox account, you can log into Dropbox and then store stuff out in the cloud. Now, it's more than just storage. It can also do synchronization. So let's say I have, like their little diagram, let's say I have a tablet, a laptop, a phone, and a desktop machine, okay? And I've got some photos that I want to carry around, but I want to carry them everywhere. So you could put them all out on the cloud. And so no matter where I go to the cloud to view my photos. That is an option. Dropbox allows you to do that. It also allows you one more thing, and that is it will automatically synchronize, if you want it to, on all these devices. So I create a photo on my laptop, I store it up to the cloud, and as soon as my tablet wakes up, or my phone, or my desktop machine, it says, hey, I realize there's a new version of this on the cloud. Would you like to update? And so it keeps all my files synchronized. So if I have a directory full of photos on 4 devices, I have a directory for photos on my phone, my tablet, my laptop, and my desktop. They all end up having the exact same files. Now that's good for me because I don't necessarily want to go up to the cloud every single time. Now if I'm over at somebody else's house, I don't have my phone, don't have my laptop, don't have my tablet, well then I can use the cloud version of it all. But I kind of like the synchronization part. Kind of cool. So let's continue. On page 353 you talk about optical discs, and you guys know what we're talking about. We're talking about just plain old CD-ROMs, right? And so you can buy, you know, just a plain old everyday CD-ROM kind of a thing. So an optical disc contains a flat, round, portable disc made of metal, plastic, and lacquer that's written to and read by a laser. I will tell you, in the early days of these, we were trying to destroy a few of these, you know, because you know, it had sensitive information on them. And so I thought, I'll just pop it. You know, it's just plastic. You know, it kind of bends a little bit. So I just take it and break it. So I just took this little thing and just went, popped it. Well, it broke the polycarbonate, you know, disc, but spewed all this mylar plastic. It was like confetti. Like, you know those little confetti party poppers you used to be able to get? You pull this little string and it goes, poof, with all sorts of stuff. That's what this does. I mean, I popped this thing and it went, poof, just filled the room full of sparkly silver mylar. What a mess. Okay, back to the story. So, optical discs. There's a little diagram talking about how you have a shiny surface and lasers actually burn a little pit into the surface so that when next time a laser goes around, the light doesn't get reflected back as well, and so it can detect whether or not that's a, you know, a 0 or a 1, so to speak, in binary. So that cool little diagram there is actually not bad. Okay, one of the things that's kind of odd about these, you remember I talked about how we had tracks on the hard drive, and so you had like a cylinder, you know, you had a track starting and it went all the way around, and then it went down to the next read-write head and went around and went down to the next read-write head and down, down, and down, and that was a cylinder. Well, discs, most discs, and certainly the earlier ones, were actually designed for music, right? Remember when these things first came out? And so they were spiral. They started here and they just kept going out and out and out until they got wider and wider and went all the way in. So they don't have concentric circle tracks. They have one giant track that goes all the way up. Okay, and that was perfect for music because, you know, as long as the machine kind of kept track of where you were, you know, you could just go from one song to another without any interruption, without any access time, any seeking going on. So that's the way they were originally. That's not necessarily the way they are now, because when you buy, you know, like a DVD discs and you can format these guys as like a DVD-R and those kind of things. They don't use that. Okay, so on page 355 they talk about the different types. So a CD-ROM is the one that you get like with, you buy a piece of software and it comes from the factory. All right, so a CD read only. A CD-ROM has no write capability whatsoever. It's burnt at the factory. In fact, it's not actually, believe it or not, it's not actually created using a layer. It's actually, a laser. It's actually sort of like printed. They create like a mold, because if you had to burn one of these suckers at a laser, you know, it would take very long to punch these guys out in an assembly line. So they actually have a way that you can build something like spray Mylar and just slap something on it. So these things are pre-programmed. I hesitate to say burned, but pre-programmed at the factory. A CD-R, which is one of these guys, is designed to be written to. Now it has some problems in that you can read from it, and you can write to it, but you cannot erase something. Okay, so if I put something on here and then I come back, I go, oops, I was wrong. I have basically no choice but just to ignore that part and just write another copy out. And so, unlike a traditional disk, you know, where you erase a file and replace it, and erase a file and replace it, it doesn't take up any more storage. This, every time you add the same file, if you had the same file and you wanted to put it on there 3 times, instead of it using the same space, it's actually using 3 times as much. Okay, so it's an optical disk which can be written to one time. That's not exactly true, but cannot be erased. That's what they really mean. They're not talking about I can't run it through the burner twice. What they're saying is once it's written there, all I can do is just make the table of contents go away so that it looks like it's not there, and then write it over in a second location. A CD-RW disk is the one that can be erased. So you can go in there and say, okay, I've put this on there, and I go, you know, I made a mistake, that was dumb. Let me just start over. So you can erase a single track, or you can erase the entire disk and say, screw it, I want to start over. DVD, which stands for Digital Versatile Disc, if you talk to some people. By the way, the other one is just called Compact Disc. Okay, so CD is Compact Disc, DVD is Digital Versatile Disc. Although the name kind of changed. It was Digital Video, and there's some other variants on what that thing is actually called. So a DVD-ROM is the ones you buy the movies on, right? And it's the same kind of scenario where they're written to at the factory, and you can't write to them. And they're much, much bigger capacity than a CD-ROM. You can get a DVD-R, and then here they have DVD-R and DVD+R. And the reality of the scenario is it doesn't really matter for the vast majority of the discs burners, the CD burners, DVD burners can handle each one. It doesn't really matter. So I'm not going to go into the details. What's the difference between a -R and a +R? And then there's a DVD-RW with the plus and the minus again. And it's the same, analogous to the story we told you before about it being able to erase or not erase. Okay, so different kinds of formats, different types of limitations. And those are kind of sort of simple things that I think you should know and might actually show up on a test. Okay, so let's move on. And talking on page 358, let's talk about the enterprise version of all this. So enterprise typically needs bigger, more robust, more fault-tolerant way of storing things. And so they talk about RAID one more time. And there's 2 different ways that RAID can be used, and it's called mirroring. So I have 2 old hard drives I found in the closet. They're 200 meg, and so I put them together, and so anytime I write to this one, it automatically writes to this one as well. So I essentially have a backup copy of the exact same hard drive. So whenever I erase something over here, it erases it over here. I write to over here, it writes to over here, right? So they're bolted together, but they're exactly duplicate. And that is fantastic. If one of the hard drives fail, all you get is a little light that comes on and says, oh, by the way, one of your hard drives failed. And it's like, okay, fine, I'll get to it next week. Right? No bother, right? Because you used to have two of them, now you got one. There's no performance degradation. There's nothing. I mean, other than the fact that you're at risk and you ought to fix it. But so this mirroring option is kind of cool. And the other one is how to... hard drives originally, when they first came out, were not incredibly reliable. They were in most scenarios, right? You bought you a big computer. The only moving parts in the entire computer were the fans that keep it cool and the hard drives. Okay, right? No other moving parts. And so what do you think failed most on these machines? Fans and hard drives. That was the only thing that had a moving part. Okay, so in order to protect your investment in your data, you would take 5 or 6 of these hard drives and you do striping. So first one's called mirror. So if I had 2 disks, I would have to have a total of 4, right? You know, mirror, I have to have 2. So I could have 2 and 2, or I could have, 3 and 3, or 4 and 4. Have to be duplicated, right? And the other one is called striping. And striping means when I write to this hard drive, I'm going to write some of it over here and some of it over here. Ooh, cool. So I write, a document. Half the document is over here and half the document is over here. Now you might think, well, wait a minute, how's that going to help me any? Well, there's certain types of striping which actually makes things faster. Instead of me writing half, my entire document to one hard drive, I only write half the document to this hard drive and half the document to that hard drive. Well, if I'm splitting the load in half, that's going to make my speeds go up, isn't it? Yeah. It also makes it dangerous as hell. Because now if I lose one hard drive, I lose everything. Okay, so that type of RAID is seldom used. There's other ways you can use striping, and that is I take 5 or 6 hard drives and hook them together, and so now I'm sharing data across all these drives. So I'll write a portion over here, a portion over here, and a portion over here, and a portion over here, and then have another part. I'm not going to get into too much of the details. I'll just call it the checksum. Another piece written to another drive, so that if any one of the drives failed, it could figure out what the missing pieces are because of this little checksum thing. So if I'd lost I had 5 drives, and I lost drive number 2, went out, I'd still have all of my data. So some types of RAIDs are designed for a single drive failure. You can get another type designed for a 2-drive failure. And unfortunately, unlike the example I talked about before, where you had the mirroring, when you have a single drive failure, you do have a significant performance decrease during that period of time it takes you to go find another hard drive and plug it in. Okay, so the combination of mirror and striping is really about speed, could be. It's about having complete backups, and then the third option being able to have single drive failure or perhaps a double drive failure. Okay. On page 359, they're talking about network attached storage, NAS. And so what you do is you buy you a box and you put hard drives in it, and they're typically going to be having a RAID, and a RAID 5 or is the type where it talks about single drive failure, right? So you buy this little box and you plug these drives in and you hook it up to your network, okay? And it just shows up on your network as a storage device, just like you had another computer out there with a network share. And so you just connect to it and copy files back and forth, store whatever you want. It's actually pretty doggone cool and incredibly simple to set up. I mean, it's practically plug and play. You set things up, hit the button, and turn it on, and you're done. Okay, this is probably a good place to stop for the 15-minute mark. We'll pick this up again in just a few.